Hey guys, welcome back. Shubham this side. Now it's time to discuss non-linear data structure, which are trees and graph. So till now we have been discussing about all the linear data structure, which were arrays, then we talk about linked lists, then we also discussed about stack and queue, but it's time for us to understand the non-linear data structure. So this side is pretty important and you are going to see a different side of data structure in form of complexity, in form of solving any question, in form of visualization. So this is pretty important and it's going to be a pretty different experience than array and linked list. Now here among graph and trees, first we are going to start with tree. Remember, tree is one type or one form of graph. So first we are going to discuss about trees, its type, and then we are going to jump onto graph. So there are different type of trees. We are going to discuss them in a while. The first thing before moving forward, I want to talk about that how a structure of tree is followed. So if you remember, in linear data structure, we have one element, then it is connected with other, then other, and keep on following. But in tree, we follow a hierarchical structure. If you see, we have a node, we have an element, and then we have two other elements connected to the first element. And then we have other elements like this. So that means there is some sort of hierarchy as well as some sort of relation. Here our priority is to understand the basic structure of tree first and all the common terms. Remember, the topic itself is quite messy, this tree topic itself. So if you are a university student, it is going to be messier for you. Because if you just search about this tree on Wikipedia, you will get different type of trees. You will see different topics, then subtopics, then types, and keep on following. So the thing is, you don't have to study all of them. Since all of them are not important, there are only few selected topics that you should understand, and only that topics are important for coding interview. So if I talk about these maybe 20 or 30 type of trees, you don't have to understand much. Also, if you are a university student, your syllabus also depend upon your university, its affiliation, and all the other things. So make sure we are only going to cover the important part which is required for coding interview purpose. So if I get back here and start my discussion over tree and its structure, so the first thing that you have to remember is that if we have any element, we first convert it into a node. So this particular element is actually a node, and then it is going to be connected with other elements. Here 3 is a node, 4 is a node, 6 is a node, and all the other elements are node. So that means each element which we are going to add in a tree is going to be first converted into a node, and then it is going to be connected in a form of relationship. So the important terms that we need to understand here is node, then we need to understand about root, then about parent, then child, then leaf node, then we have to discuss about siblings. Now why I am writing these? Because these are pretty important and you have to understand each one of them. Then we are going to have edge, then levels, then there will be path, and then subtrees. So I have added them here, so that means you have to understand each one of them. So node is basically when each element is converted into a form. So I guess you understand about node. Now since this complete structure is in a hierarchy form, that means we need to start from somewhere. So that means the topmost level, the topmost node is the point from where we start is actually the root node. That means from where we begin our entire tree structure. So that is going to be a root node. In this case, 3 is our root node. That means we start any task from 3 and then it is going to be in relationship with others. Now root node is going to have a relationship of left and right, that means in the form of parent and child. So if I talk about this 3 is going to work as parent. So this is parent, and then the elements that are under it is going to be its child. So 3 is parent and 4 and 5 is child of 3. If I talk about this part, 4 is parent for 6 and 7, or 5 is parent for 8 and 9. So that is going to be important terms that you have to understand, that there is a relationship between 3 and 4 in the form of parent and child. So this is going to be important for you to understand. Now here, one more important thing is about levels. So that means to maintain our hierarchy, we denote levels. So our root node is going to be the level 0, then we are going to have level 1, and then we are going to have level 2. So as we keep adding child, we are going to keep adding levels. So suppose I add a new child here, maybe 10. So that means this is going to be level 3. So you have to understand, as we expand our tree, we are going to increase the levels. So our levels start from root node, which is level 0. Then the child of root node will be denoted as level 1. Then the child of them is going to be referred as level 2 and keep on following. So as we expand our tree structure in the form of child, we are going to expand these levels. So it is pretty important and will help you in long run. So I hope that's clear now, which is level. Then we are going to have edges. So the connection between 3 and 4 is going to happen with the edge. Now these edge have direction. In trees, we have only one direction, which is from 3 to 4. That means from parent to child. At this point of time, we are going to connect in the form of one direction, which is going from 3 to 4. Now in graph, we will be talking about this again. But at this point of time, the edge is going to be connected in the form of 3 and 4, and the direction is from 3 to 4. So if we talk about traversal, if we talk about visiting different node, if we are going to start with 3, we can visit 4 and 5. But we cannot go from 4 to 3. We can only go from 3 to 4. So that is the direction that we have to understand. So that's done for edges. Now the next thing is about sibling. So node with same parent are referred as sibling. So that means 4 and 5 are child of 3. That means 4 and 5 are sibling. If I talk about 6 and 7, they are sibling. 6 and 8, nope, they are not sibling. So that means the elements which are child of a particular element is going to be referred as sibling. That means same parent. Two nodes, if they have same parent, they are referred as sibling. I hope that's clear now. Now the next thing is about leaf node. So the last element which don't have any child is known as leaf node. So any node which don't have any child is known as leaf node. So suppose if I have maybe one element here as 10. So this is a leaf node. This is a leaf node because it don't have any child. This is not a leaf node because it has one child. This is a leaf node. This is a leaf node. So that means any element, any node which don't have any child is referred as leaf node. I hope that's clear. Now the next thing is path. So path is pretty important. When we say give a path from 3 to 9, it is going to be 3 connected with 5 and then 5 connected with 9. So this is going to be the path. If I talk about the longest path from root node to leaf node, it is going to be 3 to 4 to 7 to 10. This is going to be a path. Since this is the longest path, that is why. Otherwise from 3 to 5, 5 to 9 is also a path from root to leaf node. But here this is not the longest path. This is actually the longest path. So you have to understand these basic terms. We will be discussing about them again and again in terms of questions, in terms of different other discussion. So you just need to have basic idea. Now the next thing is subtrees. So this is actually a big tree that you already have information, but then we can create subtrees to perform a separate function. Suppose this part can be referred as one subtree, or maybe if I remove this for now, just to make things easy, this is going to be referred as one other subtree. Now even if they have child, it will be included in this particular subtree. So there are several times that we need to perform recursive call, maybe other functions that we need to perform on subtrees again and again. That means we have 3, then we divide this in a subtree, then we divide every element in a subtree. So it's easy for us to perform a particular task. Now this was it. This was the basic terms that you should have understanding. I think you have understanding about node, you have understanding about root, then there is parent, child, leaf node, sibling, edge, levels, path and subtree. Make sure this is the basic of tree and you should have understanding about them. Now this looks fine, but you might be thinking, okay, how this is relevant in real life, how we are going to utilize these concepts. So the simple thing is, let's jump onto a web page. Let us visit a website called facebook.com. So here you will have a basic idea what I am actually doing. So this is my status which I am referring as node A, and this is actually a parent status. So that means I have created a status and I'm referring it as root node. Now every time I'm going to comment, I'm going to create a child for this root node. Now here if you look, I'm actually commenting and these are the child. These are referred as child in Facebook behind the scene. So this is going to be my parent, which is my status, and these are child. Now if I reply to them, that means I'm creating child for these particular comments. So these are the nodes, these are the elements which are connected with node B. So basically what I did is I posted a status which is referred as root node, and then I commented them. So this is going to be my comment, and then I replied to these comments. So these are going to be their child. Now suppose I do more comments, I'm going to add them as child. So this is going to be 10, then maybe this is a comment, then keep on following. So that's how a tree data structure looks like. Now here it is not important for you to visualize only 3, 4 or 5 items. Tree can be a complicated structure. So if I take a different structure, so this is also a tree. At starting we have 1, 2, 3, then we have again 2 child, then we have 3 child. So it can be anything. By default, the only restriction we have is we are going to follow a hierarchy that is in the form of levels. And then we have a root node that creates a parent-child relationship, and we can only go from parent to child. Now if I talk about a different example, so if I just right click here, click on this inspect, this DOM is also an example of tree data structure. So if I just fold this, so what I'm going to do is here we have our main tag which is HTML. Then inside this we have different subtags which is head, then body, and then there are several other tags. Now inside my body there are several other child. So we are going to have a div, and then inside this we have 3 different child. For this we have other child. So that means we are going to follow a proper structure. And if you see each and every website in this world, you can open Wikipedia, you can open any website, just right click, click on inspect, and you will see a structure. So each structure has a child, has a parent. You can see that we have HTML, then we have head and body. Inside this body we have several div classes. Inside this div classes we again have child, and keep on following. So that's how our website is built. That's how our DOM works. So that means there are real life examples, there are real life applications that will help you to understand and just have a basic idea about tree. Now the other important example that will help you to understand this tree is if you play chess. If you have ever played chess with computer, maybe few years back, at this point of time we have artificial intelligence that help computer to decide moves. But earlier everything was hard coded. So that means if we move any element in our chess base, it is going to have different outcomes, and that outcomes were usually defined with the help of tree. So that means if we are moving king, then there will be a fixed number of outcomes that we can map in a tree. So if we move maybe king 1 step ahead in the front direction, we will have defined 5 steps. Maybe if we move our queen, then there will be other 2 possible structure or possible move. So everything was defined in the form of tree. The other example is family tree representation. So maybe your grandfather can be referred as root, and then all the sons, and then maybe you and your sibling, your uncle and his child. So you can represent them in the form of tree data structure. I hope you got basic idea how we deal with it. Now there are 2 important things that I want to talk about, which is the first one is that the relationship, that is parent-child relationship, is important. One child cannot have 2 parents. That means a parent can have many child, but one child can have only one parent. So this is something important, which is parent-child relationship. The second thing is direction. In tree, we always follow a direction from top to bottom, which is our hierarchical form, which is from root to leaf node. So if we have root node, we can go either it's left child or right child, and then we can again, this is referred as root for this subtree. So we can either go on to left child or right child. So that's how we are going to follow. So each node can be either a parent or maybe a child or maybe both. So here if you look this, 4 is actually child of 3 but also the parent of 6. So these are some relationships that you have to keep and notice. So our second point was direction. I hope this gives you a basic idea. Now let me clear this up and talk about a basic exercise that will help you to understand this structure better. So let me clear this up for now. Now here your task is to mention each one of them. So I think we just discussed this, but your task is to get information of each one of them. At this point of time I think you already know, but let's do this. So pause this lecture and see about node, then discuss about which one is the root node, then discuss which of these node are parent node, then discuss which of these node are child node, and keep on following. So let's do that. Here you just need to find these values. So just pause this lecture and then see what are the values that you are going to get. Now the first thing I'm going to talk about root node. So for root node we are going to get a result of 3, which is our 3 node, and this is going to be our root node. Then parent, at this point of time 3 is also a parent, 4 is parent, as well as 5 is parent. So that is going to be a result, that is 3, 4 and 5 node. Then about child, here 4 is child, 5 is child, 6, 7, 8 and 9 is also a child. Except 3 all are child. So that is 4, 5, 6, 7, 8 and 9, which are our child. Then about leaf node, all the nodes which are at the bottom, which is 6, 7, 8 and 9 are going to be a leaf node. So these are our leaf node. Then about sibling, so 4 and 5 are sibling, so this is going to be a pair, 4 and 5. Then 6 and 7 are sibling, 6 and 7, then 8 and 9. So this is going to be our sibling. That's it. Now remaining all this are edge. I think you'll have information about levels, which is going to be 0, then 1 and 2. And then we have path. So path can be from 3, 4 to 6, then 3, 4, 7, then 3, 5, 8, 3, 5, 9. And about subtrees, we have 2 subtrees, which is going to be this one and this one. That's it. Here, this was the basic introduction about trees. Now in the next lecture, let us continue our topic and then dive deep into types of trees. I hope this lecture was helpful. Thank you for following, and I see you guys in the next one.